Hi, this is part 3 of the sequencer building series. So last time we left off, we created a beat grid. We go ahead and run that. It looks a bit like that. And today we're going to look at making the cursor adjustable and in relative terms to beats per minute. So it actually sort of behaves like a sequencer. All right, well, first let me simply save as there. And I'll call this number 4. And we'll call this BPM cursor. Okay, great. All right, so let's take a minute just to think about this a little bit. What we really want to do is we want to have the cursor move according to clock time. What we have right now is we have the cursor X position moving by a frame rate. Basically here it's adding 1 every frame, 1 pixel every frame. So that means it's moving at a frame clock. So if my my draw, this looping area here, right here, draw, is moving at 60 pixels, 60 times a second, 60 frames a second, I'm going to add 60 pixels every second. So that is determining the current sort of motion and speed of my cursor right now. It's just a simple animation. Okay, so now I want to express that so we can talk about beats per minute, have it like be a proper sequencer. I want to talk about this in terms of clock time. So how do we do that? Well, we have this millisecond clock within processing, and it basically tells you, reports to you the amount of milliseconds that have transpired since you ran the sketch. That's called millis. Okay, and basically the strategy really is to map the milliseconds and map it from a certain amount of time transpiring range, a certain time range, to a pixel range. Okay, and let me clarify that a little bit. Let me go through that, do some pseudocode so you can see what I mean. Okay, if you have milliseconds coming in, okay, and if you're mapping that between, say, 0, and remember we're talking about milliseconds, 0 and 10,000, right? Okay, which is 10 seconds. So your milliseconds are coming in. It's going to go, in 10 seconds, it's going to go from 0 to 10,000, okay? And if you map that value, 0 to 10,000, as it's going from 0 to this millis, as it going from 0 to 10,000, if you map that from the left side of the canvas, whatever that is, I think it's 30, right? And then the right side, which is whatever it is, 800 or something like that. Okay, so you're gonna the map is gonna pop out a value between 30 and 800. It's basically just gonna map this range to that range. As the millis are moving from 0 to 10,000, it's gonna move from 30 to 800. Okay, so let's actually implement that using processing functions, and hopefully it'll become a little bit clearer. So the thing we want to actually change, right, is the cursor X, CSRX. That's the thing we actually want to change, the X position of the cursor. And we're going to use this map function, okay, and it takes an input, and that in this case will be milli, millis, okay, with the 2 parentheses, and that's a function that reports the amount of millis that have transpired. Okay, so we're going to map millis between 0 and a range. Well, in this case, we're just going to start with the idea that we have a fixed length of our entire sequence. So the 4 measures, whatever the 16 beats, are going to last so much time. Well, let's make a real life example now. If we have it 60 beats per minute, that's 1 beat a second. We have 16 beats, that's 16 seconds, right? Right. So 4 beats a measure, and 4 measures. So that's 16 beats. So 16 seconds. So that will be 16,000, right? Because they're milliseconds. Okay, so as millis travels, as the reported millisecond time travels between 0 and 16,000, we actually want to map that range to, and thankfully, remember from before that we had already sort of set things up with a bounding box, and we figured all these, the left and right points, the top, bottom, and the middle points of our sequencer area. So we can just simply say we're going to travel from our left to the right. Okay. Now, there's one problem with this now, in that this is great and this will work, except only for the first 16 seconds of when you run the sketch, right? and then it's done. It's not going to map anymore because you're staying strictly from 0 to 16,000. It goes from left to right. That's it. Well, we can use, in that case, we can use the modulo function. Now, modulo will just keep looping the millisecond function at a certain range. So if we say that the entire duration of our sequencer, the 4 measures, is 16,000, every 16,000 millis will reset, with the modulo. So it'll go from 0 to 16,000, 0 to 16,000, 0 to over and over and over again, no matter what millis is. Millis could be up to 500,000, but in fact, it'll report in this configuration, this modulo configuration, it will report somewhere between 0 and 16,000. And that's handy because then now we go from 0 to 16,000, and we go to left to right. Now, well, let's run that and see if that works. Okay, so this is going to be ostensibly 1 beat a minute. 1, 1,000, 2, 1,000, 1, 1,000, 2, 1,000. Hopefully that's the case, and I think it probably is. And let's see if it just loops there. Okay, and it does. Okay. Well, remember we had sort of forced a loop here, so we can actually get rid of this now because we're hoping that this will take care of that now. So let's just comment that out right now and run that and see if that does work. Okay. Measure number 2. Could have made it go faster, I suppose, but what's another 16 seconds? Okay, and it does. It works. That's great. So now we don't have to actually force it. So basically this was saying when it reaches the very right edge, reset the cursor X to left. But we actually don't need this anymore because we're doing this looping animation with this modulo factor. All right. Well, that's great. That's about 80% of the battle right there. So we have our cursor animated in terms of clock time, right? We're counting from 0 to 16,000. It's just being mapped from the left side of our sequencer area to the right side of our sequencer area. And then that's being stored in the variable cursor X. And then the cursor X is here and here, moving our line, right? And that's great if we want to do all of our pieces at 60 beats per minute. But in fact, we probably want to change that, so we'll make that a variable. So let's call that sequence length, maybe, seq length, len, call that. And let's not forget to declare our variable up here. We'll just call these cursor animation variables. Okay, and what do we call that? It's a float, and we call it cursor. Sequence, seqlen, sequence length. Okay, now this is good. Like I said, it's about 80% there, 80% of the battle. We have a sequence length, total duration, but how do we express that in beats per minute? All right. Well, again, let's put our thinking caps on. Take a little bit of time and work this through. Okay, if a total duration is, say, 16,000, so obviously we want to take the sequence length, so we can, to get number of seconds, we take, millis divided by 1,000, right? So we have to at least do that. So we have to take our, let's take our sequence length, which is expressed in milliseconds, and let's divide by 1,000. So that will give us our sequence in seconds, right? Well, we'll just leave all this in here for now. And okay, so if we have sequence length in seconds, right, then we have to figure out what do we have to figure out? I guess we could figure out in terms of beats. Can we do that? So yeah, that's how we do that. So if we want to do beats per minute, this is to figure out beats per second, right? We have how many beats, I guess. That's how we do it. That's easy enough. So we have number of beats, which is equal to, what is it, 64? No, I'm sorry. Is it 16 beats? Yeah, 16 beats. Okay. Okay. So, and we actually divide the sequence length, we'll call it sequence length seconds, by the number of beats. Is that correct? And that'll give us beats per second. No, it's the other way around, right? Number of beats divided by the number of seconds, right? Right? Does that make sense? The number of beats divided by the sequence length in seconds will give us beats per second. And then if we do beats per second, we have to do some, we'll have to multiply it by 60, and that'll give us beats per minute. That's right. So BPS times 60 equals BPM. Right? Is that correct? Well, let's work that through with a practical example. So we know, for example, 120 beats per minute means 2 beats per second. Is that correct? So if we have 120 beats a minute, right? And we divide by 60, that's 2 beats per second, right? So we have 2 beats per second. We have a number 16, 2 beats per second. That means our 16 beats will last 32, sorry, it'll last 8 seconds. That's right. So let's pop that in there. We have 8 seconds. It's a sequence length. Number of beats 16. 16 divided by 8 is 2. That works out, 2 beats per second. Okay. And of course, milliseconds, we know, just times 1,000. All right. So let's just do all this in reverse, basically. So at some point, and we'll probably just do this in setup. Okay. Well, let's just copy this over. We'll have a float, and we'll call it BPM. Okay, and let's just make this equal to 120 for now. All right. And I suppose we can do this anywhere. We'll just continue on. Calculate BPM. BPM. Okay, and we'll put that in. So, oh, I'm sorry. We actually want to calculate sequence length from BPM, right? So we have a BPM equals 120. We're going to have to add some extra variables here. Float, SEQLEN. Oh, we already have that, right? Yeah, sorry. So we're gonna calculate the sequence length from the beats per minute. All right. So if we take beats per minute, we're just gonna basically do everything in reverse. So we're gonna take BPM, and we're gonna divide that by 60, right? And that'll equal beats per second, right? And let's just put a parentheses. We'll just do all this all together, be a little bit more efficient. I could make separate variables for each of these, and that will maybe be a little bit clearer, but you can follow along, I think. So that's beats per second, right? And if we have beats per second, then we have to figure out what the sequence length is, and that's basically that divided by that. So if we times sequence length, and basically divide by the number of beats, right? If we have beats per second, I'm sorry, times the number of beats, right? We have a number of beats per second, and we multiply that by the number of beats. We're going to have our entire sequence length. No, isn't it the number of beats still divided by beats per second, right? So we have a number of beats here. So we'll just say 16, right? And then divided by beats per second. So the total number of beats divided by the beats per second. So in this case, it's 120. We have 16 beats. We're divided by 2 beats per second. That give us a sequence length of 8, right? So we can then say SEQLEN equals, right? Okay. Yeah, I think your brain needs to be working pretty good You have to have your coffee or your orange juice to get these mental masks going on. So basically, yes, let's just review very quickly. Here we calculate beats per second, right? That's easy enough. Take beats per minute, divide by 60, it's going to equal beats per second. And we just sort of do a quick thought check. So if we have 60 beats per minute, that's 1 beat per second. 60 divided by 60 is 1. That's right. If you have 120 beats per minute, that's 2 beats per second. 120 divided by 60 becomes 2. That's perfect. Okay. Now, if we have 16, which is our total number of beats, and we divide that by 2, that equals 8. And that makes sense because if it's a 120 BPM, 16 beats is going to last 8 seconds, right? And there we go. We have 4 things. So we can actually just delete these. And we understand now that our sequence length can be calculated this way from beats per minute. And then this mapping function simply maps the sequence length. So it uses this modulo to loop, right? Loop the sequence length. So now if it's at 120, it's going to go 0 to 8,000, 0 to 8,000, loop that. And then it's going to map 0 to 8,000 from left to right. So hopefully this works. Run. Whoa. That's way too fast, isn't it? Okay. So I suppose our calculations are wrong. Oh, and of course, the one thing I did not, so it's actually 1,000 times. I just forgot to convert that to milliseconds. So this is the sequence length in seconds. What we want to do is we want actually the sequence length in milliseconds. So I'll put another parentheses in there just because I'm very careful about order of operations, and we'll times by 1,000. Okay. And there we go. 1,000, 2, 1,000, 3, 1,000, 4, 1,000. That's right. That seems about right to me. Okay. And of course, if we want to change our beats per minute to say like 80. So now we really have a sequencer with a cursor that's moving very, very accurately, or hopefully fairly accurately in terms of beats per minute. Right. All right, well, I think I'll end this tutorial there, or this sequence here, and next time we will tackle how to put on some beat markers, put in some things that actually represent samples or beats.